Hello everyone, thanks for joining today's webinar. This webinar is presented by William Lucas from EPCC. He will talk about software packages in HPC with Spack and EasyBuild. And the floor is yours, William.
Hey, thanks, Juan. Okay, so thanks for coming. So I'm just going to spend the next wee bit talking to you all about building and installing and managing software packages and HPC systems using Spack and EasyBuild. So just a quick overview of what we'll be talking about. First of all, what kinds of situations we find ourselves in when we're trying to manage software in this way on HPC systems. Then I'll talk about both Spack and EasyBuild, which I think are both two incredibly powerful, useful tools. What they are all about and how they're used, but this is just, and then a brief comparison between the two. Descriptions of how they're used will be quite brief, so I've put a disclaimer here. This is not going to be a tutorial because unfortunately an hour at most is nowhere near enough time to cover everything here. But hopefully this will be a useful introduction for you, a basic primer on how they're used, and it will give you a little taster of a feel of what they can maybe do to help you. So if we get going, of course, this is all focused on HPC. These tools are not really things which you would want to use on your home desktop or laptop because of the situation that you find yourself in when managing software on HPC systems. In these systems, you often have users come on, they will build their own software a lot of the time. But if a lot of users, say from some specific research group, are all using the same tool, then you will want to be able to provide software for them to use. Perhaps you have a lot of CP2K or GROMACS users who don't really know or care too much about building software. All you want to do in this case is enable them to log in, load that software, probably through an environments module to make it easy for them, and then they can just get going running whatever simulations they want. This centrally sourced software that we're providing for the users will, we want to have performance above everything else. So we're going to build this likely from source on the system. We want to provide the dependencies needed to build that from source. Depending on what it is, it's difficult to build. Some software is just very hard to build, unfortunately. And on top of this, you may want to provide different versions, each of each software package, each of which may come with its own issues which you need to deal with. Consequences of that are that you potentially need to spend quite a lot of time working out what you need to do. If you find 6 months, a year down the line that you need to rebuild GROMACS version, whatever again, but you didn't make notes, and because of the way that your cluster is set up, there are some hoops to jump through, you may just find that you need to waste even more time working out how to do it all over again. So first thing you can do, of course, is keep notes on what you do. So on a lot of the EPCC clusters, we keep notes how to do this on a GitHub repository. You can see the link there, which is also maybe a decent first stop if you're wondering how to do any of this yourself. So the first thing, obviously, is keep notes. Or rather than potentially spend a lot of time doing this over and over again, if you want to rebuild software, install it again, rebuild software, install it again, is to use a build system. We're going to talk about two here, which are, of course, in the title of this session, which are Spack and EasyBuild. These automate the entire build process, resolving dependencies along the way. They will create module files for you, so your users can immediately jump in and start using whatever you've just built. They come with some extra neat bits on the side. And essentially what these are doing is they're taking those notes which you would keep yourself, and they are using machine readable Python in both cases versions of those build instructions and automating the process for you. So if this is what you find yourself doing a lot, there's potentially a good increase in efficiency here for you. So giving Spack a quick overview, we'll do Spack first, then we'll talk after Spack about EasyBuild. So this was created by Todd Gamlin at Lawrence Livermore. There's a lot of community support. There are others, I think, Lawrence Livermore helping out, but people providing packages for Spack come from all over. There's a really nice community effort there, I think. It's written in Python, requires very commonly available versions. There are a few more requirements, but these are things which will be almost certainly available. Things like curl and I think Git are needed. It's very simply installed. You just clone from GitHub. You can do this site-wide. If you're thinking about installing it for a complete cluster, then you can create a central installation. Or if you want to just mess around with it in the local home directory, you can just clone it into your home directory and start messing around with it, investigating if it's right for you. Once it's cloned, you just run a setup script very quickly in Bash and then run it straight away on the command line through the Spack command. It's a bit like Git in that everything inside Spack is run through subcommands from the Spack command itself. To just get going in Spack, very simply, it is very, very fast. You can load it up and immediately you can attempt to install things by just doing Spack install the name of the package that you want to run. There's a little bit of configuration you may need to do depending on the compilers that you want to use. But really, that's a single command you need to run. The Spack documentation is very good, and we'll walk you through that. So you can almost immediately run something like, if you want to install HDF5, just do Spack install HDF5. I just set up an OpenSUSE VM to just get some output and show what happens. And what you find happening is a lot. So there's some text here. I hope it's big enough for you to read. It says that there's an input spec of HDF5 concretized, and then a whole load of output. And this is only the first few lines. It goes way on down below. So obviously Spack's immediately getting to work and doing quite a bit. What you're actually seeing is the concretizer. The concretizer is, if you like, the central engine of Spack, and I think it's where Spack really shows its power. We asked Spack to install HDF5 with nothing beyond that. Obviously, there's quite a lot missing there, and that's what the concretizer has to work out. It wants to know which version of HDF5 should it install. If it doesn't have a version, how can it get the source? How can it build it? It knows absolutely nothing. It, of course, needs to know which compiler should it use to build HDF5. It should also need to know which version of that compiler. It needs to know which build options should it use. HDF5 is fairly configurable. There are some things you may want to enable, but while you build, there are some things you probably don't want. A big thing is the dependencies. You can work out the dependencies yourself and install them, but that may take quite a bit of work. The concretizer will walk through each package, starting from HDF5, and work out what's needed for it. And then, for each of those dependencies, it will do the same again. Which version of that dependency should be built and installed, and what options should it use? So the concretizer takes that absolutely bare bones request of install HDF5 and fills it out into an actual set of instructions that Spack should go ahead and perform. What packages, what versions, what compilers, what options. And then once it's worked that all out, it will go ahead, of course, depending on what dependencies are available and what dependencies they are and what you've requested, that may take quite some time to get everything built. If I just go back quickly, you can see from absolutely nothing, you can pick out a few bits. So this is HDF5. It's also going to install OpenMPI, HWLock, libpci access, M4, and as I say, more below that I truncated. So there's quite a long list, quite a long graph of dependencies if you're starting from absolutely nothing that will have to be built and installed. Rather than just always going ahead with these bare bones specs, as they're called, just install HDF5, we can override the best options. I say best rather than default because the defaults may be overridden if things turn out to conflict with one another. The concretizer's a big part of its job is to work out what options do not conflict, what will actually work, and go ahead with it. So to go ahead with these extra options rather than just the best ones that the concretizer would pick out for us, you add these as postfixes to the package spec. So you can choose any package version by appending it with an @ symbol afterwards. You can pick the compiler to be used with a little %sign. Any options, you can override defaults by enabling them with a +sign or disabling them with a tilde. And any dependencies you can do the same for. So you can specify which dependencies to use. These are maybe you choosing whether you want MPI to be provided by OpenMPI or by mpitch. And you can then, for those dependencies, then choose versions and options again by doing the exact same. So as an example, where before we just said Spack install HDF5, we could provide this longer spec here. So this is now saying that we want HDF5 and specifically version 1.10.6, compiled using GCC. More than that, GCC version 6.3.0. HDF5 will have Fortran support enabled. And for MPI, it's going to use OpenMPI version 4.0.3. And you can go as overboard as you like with these specs, assuming that you don't choose anything conflicting in there. Or you can again go as bare bones as you like, and the concretizer will fill in the gaps and work out the dependencies as necessary. A few tips for this. So you, of course, will not always want to go ahead straight away and start building and installing, particularly if it's something which will potentially take, well, hours perhaps, depending on what it is. So you can use the Spack spec command, followed by an install spec, again as bare bones or as detailed as you like. That'll check that the conflicts are not there, that what you've requested makes sense. And then it will output the first set of output that you get if you were actually running an install command, which is to output the full install spec. So what you've requested with the full set of build options, versions, compilers, and so on, and the same for every dependency that will be needed to do that. Spack has a huge number of packages available. I think it's certainly in the thousands. I did know the number a few months ago, but it's left my head. But you can bring those all up with Spack list and then give it a search term, take a look through them. I've found that the vast majority of software that I've been looking at under Spack has been available. I think it's got very good coverage. As I say, the community support for packages is great. And of the packages currently installed, you can run Spack find, and again, give it an optional search term if you like, if you want to narrow it down, to show that everything that's there. And you can run Spack uninstall once you've found something perhaps that you don't need anymore, or just made a mistake in installing. You can just run Spack uninstall and it will remove it for you. It can be a little confusing sometimes if a lot of similar packages are installed, and this can be the case, I think, with Spack. If you ask for things with perhaps very slightly different, say, compilers, if you want to install something the same but with different compilers, you might find that you end up with several versions of M4 or fairly low-level tools. I think this is a result of the way that the concretizer is currently working, but as I understand it, I think there's a new version of the concretizer in development, which I believe will do a much better job at reducing this clutter. But you can always distinguish a package because every installed package receives its own unique hash. And that Spack finds command, you can give it an extra L option, upper for full or truncate it with lowercase, to show those hashes. And you can then refer to those at any point in any Spack command by prepending them with a /. So for example, on my VM, I found I had an OpenMPI installation with this WGH7DTV as the first part of its hash. I could then install anything, saying specifically I'd like it to use that as its OpenMPI dependency by just including it exactly as before with a little circumflex after the main spec. Or if I wanted to uninstall that version, that particular OpenMPI installation, I could do the same with a / and then the hash. Spack, I think, is fairly fully featured, so it can do more. I mentioned at the beginning that both tools can generate module files for you automatically. I think this is very useful. It certainly helps you get going on the user end quickly and helps you test software quickly. If you can just straight away do a module load and then get going with it. But it has full package management capabilities, so all those, all the modules, so all the packages that Spack installs, you can uninstall. You can, I think there are upgrade capabilities. Spack environments allow you to organize software together, so you can install lots of software packages together. You can create complete stacks of potentially quite a lot of software that you want to deploy to users in a single environment if you wanted. Each environment has its own preferences, which you can customize to whatever you need. And I think a fairly new feature is using software matrices. So you can tell Spack to install, say you wanted to provide some simulation software compiled across several versions using several different MPI libraries, again at different versions, and you could construct a matrix to build every combination of the two versions automatically. And of course, there's configuration beyond that. So you can choose your preferred versions or providers of software. You maybe want to make, say, MPI available, but would prefer to build with NPitch wherever possible. You can choose where to install, and there's quite a lot of customization for the generation of module files, which is quite handy. It may be that although Spack is installing AutoMake and M4 and other tools to use internally, you'd rather not make those visible to users, so you simply blacklist them, and Spack will use them happily inside itself, but those module files will not be generated for users to see and use. Okay, so that's really as far as I was going to go for Spack. So see, this is really a sort of very brief introduction to the capabilities of them. So Spack's done, and we'll move on to EasyBuild. So EasyBuild again has, I think, quite. Oh, I've got a question coming. I'll just quickly go and answer that. Provided Spack is installed centrally, can non-root users install packages into home? I believe they can. I believe that a central installation of Spack should be configurable on the user end to run and install things locally. I'm not entirely sure about that, but even if it weren't, it would be literally 3, 4, 5 lines of commands to get their own local installation running, which should then by default use the configuration of the site's installation. Okay, so EasyBuild. Oh, and another question, can an existing MPI package be used rather than one downloaded by a Spack? Yes, it can. So part of this the Spack configuration would allow you to list any externally provided software. So this maybe would be maybe if you're using HPE's MPI or Intel compilers or something, you can tell Spack, don't worry about installing MPI. There's an MPI module here, just load it and use that software instead. Okay, let's carry on, get going with EasyBuild. So yes, so like Spack, EasyBuild has, I think, some pretty wide support from across the world. So the lead developer, Kenneth Foster, is at Ghent University, but the actual developers for EasyBuild and the people providing the ability for EasyBuild to build and install various software come from all over. It's also written in Python, again, versions which you likely have available, and a few simple requirements which you will have. Something it does require extra is that a module system does have to be installed, but given you'll be using this on a cluster anyway, that's almost certainly going to be the case. There are a few ways to install it. If you want, you can get a bit more hands-on and do it yourself with pip or easy install, which is simple. Even simpler, there's a bootstrapping script which you simply copy and run, and this will use EasyBuild to install EasyBuild, which I think is great. And this has the bonus of providing an EasyBuild module, which you can straight away go ahead and load and start using EasyBuild. And Spack manage patch dependencies. I believe it does. I believe it does. Okay, and okay. Spack is updated, I think, really just by doing a git pull again. Okay. And back to EasyBuild. So yes, like Spack, EasyBuild you can install locally for users, or if you yourself want to do some testing with it, or you can have a site-wide installation. And once it's on the path, so you can either run that module if you did the bootstrapping step, or just load it into the path, and then it's available via the EB command. So if you go the route of installing via pip or easy install, you might choose to install the 3 components of EasyBuild. So you can run, I see Togambin's here and just answered it. Fantastic, thank you. So yes, so EasyBuild the EasyBuild framework itself manages is the system itself. Then you have easy blocks. So these are Python codelets, I'm going to call them, which are each instructions on how you perform the install technique in question. So you might have something very simple. I think this is the generic default method, is just a configure, make, install step. Except here you have a block of Python code running within EasyBuild that says, here's how you do configure, make, install. Or you might have something much more specialized. You might have an easy block specifically for installing, for building and installing CP2K. The Easyconfigs are the third component, and these have .eb extensions. Easy blocks are Python code saying how you perform install steps. The Easyconfigs instead provide the information that the easy blocks use. So it's all very well knowing how to do a configure, make, install, but they need to know what it is that they're configuring, making, installing. So the Easyconfigs provide a URL. They provide checksums for what's being downloaded to make sure that you're getting what you think you're getting. Tell it what dependencies to use, what the build options are. what you'll see is that Easyconfigs refer to toolchains. So EasyBuild builds will each require a toolchain. And each of these, so there are two I've listed, which are the main ones that you'd be likely to come across, are FOSS and Intel. And you can see that these provide the general compilers and libraries that you would need to use when installing some simulation software or support library. In particular, what you want are GCC, a compiler, MPI, numerical libraries. So a given tool chain will say, what are we doing? Are we using GCC and OpenMPI, OpenBlast, ScalarPack, FSW? Or if we're doing Intel, then we'd be using the Intel software. And the tool chains have versions themselves which say, well, okay, what version is GCC? What version is OpenMPI? So likely what you would do would be you would select a tool chain, relying on the versions that you think are what you need and which work for the software versions that you want to install, and you would run with that. So you'd maybe pick FOSS 2019A would be the version, and this would provide a recent version of GCC, recent OpenMPI, and so on. So mirroring the very, very basic introduction with Spack, here's installing HDF5 with EasyBuild. So rather than say install HDF5, we run EB, S, and then we're doing a little search pattern for HDF5. So EB is the general EasyBuild command, -S is the search option, and then we're just doing a regex search for anything beginning with HDF5. And this is going to search all of the Easyconfigs in the default location, the robot location, I believe it's referred to as, and pulls up all of them which install HDF5 beginning. Other Easyconfigs will refer to it. So H5Pi, for example, will include an HDF5 in the name. We don't want to install H5Pi, we want to install HDF5, so we'll just say, just beginning with HDF5, please. So that will then show us a list of Easyconfigs, which will tell EasyBuild how to install HDF5. We pick the version we want, and we pick the toolchain version we want. So we can choose, in this example here, HDF5 1.8.20, and it's going to use the FOSS 2018A toolchain, which means that it's going to build HDF5 using GCC 6.4.0, OpenMPI 2.1.2, and the other versions there for OpenBlast, ScalarPack, and FFTW. Once we've selected that that is the Easyconfig we want to install, we just give that name straight to EasyBuild, which will then go ahead and use the information of the Easyconfig, apply it to the, you can see this is the EB_HDF5 EasyBlock, our EasyBuild specialized EasyBlock instructions on how to go through the HDF5 build step. This, however, probably won't work if you give it a go straight away just using this command as is, because I haven't considered at all the dependencies that are required. To tell EasyBuild to go ahead with the dependency resolution, walk down the tree of them as they're provided, as they're specified in each Easyconfig, and if they aren't present, build them. You just give it the robot option, and just check, see what it looks like without actually installing. Then you can give it the D option as well for a dry run, and it will just output and then stop. So if I do a dry run back on my VM that I'm using just for this, then there's some more writing, and it's just saying found the Easyconfig, dry run, This is what you would need. The ones marked with an X are already installed, so it's going to not bother installing M4. That's available. Zlib's already there. Help2Man. It will install Flex, bin utils, and again, this is truncated because there's a fair amount of output. But this is saying EasyBuild knows what it has to do to install HDF5 using that toolchain. As soon as the dry run option is taken away, it'll do it. So it may be that you're perfectly happy using the defaults. It may be that you would prefer to customize things a little. So what you can do, you can make some changes in the command line when performing a build and install. So for example, if you were doing the same one as before, HDF5 1.8.20, FOSS 2018A, but we can instead use the try toolchain version option to change that up to 2019A. And it will simply do exactly what it would have done before, but it will swap out right down the chain of dependencies, FOSS 2018A for 2019A. Or if you want to instead try building with the Intel toolchain, so Intel compilers, Intel MPI, MKL, you can use the try toolchain option. There are other options as well. There are, depending on what's being installed, there are potentially quite a few options, and you can change these on the command line by doing try amend variable equals value. You can check what options are available by just running an eb-a-e and then the name of the EasyBlock command. So this is what the Easyconfig for that HDF5 installation would actually look like. So I just copied and pasted it straight in here. You can see it's fairly simple. So you can modify these themselves as much as you like. And it's fairly hard, I think, to go wrong here. Everything, it's just a sequence of key value assignments. So we're saying the name of the software is HDF5, the version is 1.8.20, some helpful metadata. We can see straight away what the tool chain is and version and options. Alexander's asking, where are EB files located? Can user create custom? Yes, you can. If you go ahead with the Bootstrap installation, then you'll find an EasyBuild. Well, as part of the Bootstrap installation, you'll select where you want it to be installed. You go to that location, head up a few directories, and there's a directory called Easyconfigs, and they're all listed there in directories by the alphabet. You can just jump in, take a look at them, copy, edit them as you like, add your own. Yes, absolutely. And of course, something important is you can see there the dependencies being listed. Just got a question. When to use Spack, when to use EasyBuild? That's what we're going to cover at the very end of the talk. Because I think there are enough differences that sometimes you'd want to use one and then the other. Yes, so the second from last thing you can see in this Easyconfig is this dependencies section where it's listed Zlib and szip and versions for them. And this is how EasyBuild resolves the dependencies. And you can modify this if you like to use external software if you'd like as well. And at the bottom, module class data just says when you create the module file, you can stick it in a data directory, so it keeps the modules it generates quite tidy. So if you prefer things to be more permanent than just changing it and providing options at the command line at build time, if you were creating an entirely new version, say for a new version of the software, then you can just write a new Easyconfig. So as I say, there's a directory available once you install the EasyBuild, and you can just jump in. And if you just wanted to say change the version of something, you could very easily copy and modify an existing tool chain. You might want to do any of the things here. So there are options for the toolchain options. Do you want to use MPI or not? Some easy blocks, depending on what's being installed, have very useful and indeed important extra options. So the example I'm giving here is if you're trying to build CP2K, then you may, depending on how you want people to use it on your cluster, want them to use pure MPI, or you may want them to use MPI, OpenMP hybrids, or both. To have EasyBuild build CP2K either way, you simply provide a line in the Easyconfig and set this variable type to either popped PSMP, and it will go ahead and build in that way. If you wanted to have both, then you'd probably want to have two Easyconfigs, one for each. And you can always check. So if you know the easy block being used, and it's almost always going to be something like the name of the actual package, then you can just run that command I mentioned a few slides ago, eb-a, with that easy block name to check what options are available. And you can customize as much as you like. So once this is done, once you've selected or written, in that case, the Easyconfig that you want, it will build it, test it, install it in the configured local location. It will provide you a nice module file for the right environment. Yes, I didn't mention that. So both EasyBuild and Spack are perfectly fine for either Tickle or LMOD environments. It's just a matter of configuring them to know which one you want to use. So it will generate the module file, and then at that point you can load it and start using it. And as a quick plug, I know that the EasyBuild developers will be doing a full-on, I think, training session next week on Tuesday. This, from the looks of it, will go into a lot of detail, a lot of depth, so should be a really good way to get going, I imagine. So if this does get you interested, I think I'd recommend attending that session. I'm intending to do it myself. So now, considering when you would want to use either of them, you probably would never want to use both on a cluster, although you could do, there's nothing to stop you. It just might get a little confusing, I think, for you and users if they are going through Spack or EasyBuild. So probably you would only want to use one or the other. I think they're both very powerful tools. I think they're both fantastic. Depending on your situation, you should choose probably one of them, not two. And it's also possible that you may want to use neither of them if that's the situation that you're in. So I think for Spack, I think the concretizer is amazing. I think it does a fantastic job of things. And as I say, I believe there's an even better version on the way. I'm not sure if that's still in development or already out. I haven't checked in a week or two. But it's fantastic. But at the same time, it does depend. It can lead, as I say, to very similar packages being used, being installed. If you aren't careful, if you don't specify things carefully, you can end up with a few. And also, the concretizer is fantastic, but if you do use a package which maybe hasn't been updated in a while, then you can end up with some strange occurrences happening. Perhaps you come out with something that should be or is listed as being compatible, but actually isn't. I mean, in a way that's entirely expected. It's impossible for people to test every single combination of every package with every version of every dependency and every version of every compiler. the packages will list what is known to be incompatible, and most of the time that's perfectly good, but you can come across an edge case where something weird which has never been tried before turns up and you have to jump in and fix it yourself. Spack also has really good package management capabilities, and I think these are, again, getting better over time. EasyBuild has the EasyBlocks and Easyconfigs. These are provided centrally. If you do the bootstrap installation, they'll be there waiting for you. I don't think it's quite as immediate in changing options as Spack allows you to be. So there are those command line options where you can change some things around, but I don't think there's quite the immediacy of Spack as just providing an extra little tidbit on the end of the Spack of the install spec to change the build entirely, perhaps. But it isn't that hard to do. It's just not quite as immediate. I also think Spack does have potential to provide unnecessary packages that it wouldn't really need to install again. However, the reliance on Toolchains, I think, keeps that down. I think it keeps it by default more manageable than Spack possibly does. And EasyBuild is also very stable, I think, and it makes reproducing software environments quite easy. It may be, however, that you want complete control over your installation. It may be that you want to install things in strange places. It may be that you want to do unusual things with them. If you really do need to maintain absolute control over the way that your system is set up, then really at that point, doing a manual installation is the only way to achieve that. I doubt that will be the case for a lot of people. I think that probably Spack and EasyBuild give most people enough control, however, that for them there's real potential to reduce time and effort when you're with getting new software set up and installed. And I've been apparently a bit quicker than I did in my practice runs because that's me at the end. So I hope that's at least been something to get people interested in both tools. I say I think they're both really useful, can potentially save you a lot of pain. So if you're experiencing pain doing this, I'd go ahead and investigate them both, see what you think would work for you. Okay, thanks. Now we can have questions from anyone if they have them.
Somebody asked earlier about what will be used on ARCHER2. I don't know if you know the answer to that yet, William.
Oh, yes. So this has come out of some time looking at both on ARCHER2, and we have settled probably on using EasyBuild, we think, mainly because we felt that the stability was really what we wanted. I think probably Spack would do great, but ARCHER2 we want sort of absolute 100%, well, or as close as possible, no issues down the line if upgrading. I haven't tried Spack on OpenHPC, sorry. It seems strange to me that it would find integrating with LMOD tricky. I found tests on VMs and on one of our clusters, it did really well, I thought. But on HPC itself, no, I haven't, sorry. Yes, there are. So Spack is very, very customizable. You can set default configurations either site-wide, and you don't have to use environments, and you can just tell it to get going and it will use those defaults. And there are also user level customizations you can apply, and they will override. I think there are There are a good few levels. The Spack documentation is very, very thorough, and I think goes into some good detail on how to set up default configurations for your system. It's just Spack configurations are just YAML files which you put in the appropriate folder, and it's got some nice tools for showing you what they are and for telling you where a particular option, which file a particular option is coming from. So it's quite easily configurable. Well, I said that they aren't useful for I think that they could be useful. It really depends on if you have a module system available. If you want to make sure that you have, if your personal computer does actually use a lot of versions of different simulation software with various dependencies that you would be expected to go ahead and build, then I would absolutely go ahead and give it a go. But the major use case for these tools is on clusters, I believe. So Spack you can do quite easily. Quite easily, you can tell Spack you can provide a YAML file against some of the configurations to go ahead and not bother building whatever again. And I think Kenneth's just answered this question about dependencies for me for EasyBuild, but for Spack as well, yes. So yes, you can definitely do this. Again, this is very useful if you want to use some external library, some particular version of MPI that your cluster has come with or similar. And does EasyBuild allow you to build packages with mixed toolchains, for example, some with GCC, some with Intel? This is great. I've got the developers here answering the questions for me. I'm not sure on that, actually. Kenneth, could you answer this question? Whether you can build with a mixed toolchain. Okay, Kenneth says, up to some extent, yes, you could build with a mixed toolchain, but you need to be careful. ARPAth would definitely be required. Yes, so this is something I didn't touch on. Spack by default, I believe, builds everything setting ARPaths. So everything that's built has the loading of libraries. It depends on hard baked into it. EasyBuild doesn't, but it can be set to do so the same. I personally like ARPaths, but some people I know have objections. I've got another question. I'm learning the Spack pipeline part. If we can add a spack.yaml file defining the building matrix to let the pipeline verify what packages we want. So I'm wondering there is no need to set a specific environment for CI work. So are you talking about using a Spack environment to create a software matrix, having different versions of different software in a combinatorial matrix? I have to admit, I'm not familiar with Spack pipeline. Right. Oh no, I remember reading about this. Yeah, or at least I vaguely remember reading about it. So inside the spack.yaml file, you would simply provide whichever options, whichever preferences you want for that given Spack environment, and you would tell it the matrix of software. And whenever the time came to activate that environment and then run Spack install with nothing else on there, it would go ahead and simply work out every combination within that matrix and install it. You could then, if you wanted, you could then have any other Spack environments go ahead and load any software built from that original one with the matrix together. Yes, so reading through this, yes, so both EasyBuild and Spack you can configure to work offline if you, of course, can provide the source needed in another way. Okay, so we're very nearly at the hour. So I'll say thank you to everyone for attending. And yeah, and I hope it's been useful. I hope it's given people a little taste for these two tools. Again, I would recommend at the very least considering them both because they are both very useful. And hope it's helpful. So thank you. Finally, yes, I'm going to say thank you to the two lead developers since they are here as well and they actually wrote these things for us. So thank you.